This is our video tech tip on nodal point prisms. Everybody knows surveying prisms have an offset. The common offsets are 0, -30, -40 if you're in a nodal. Again, this tech tip is particularly focusing on the nodal position. This Eclipse series, our 6400, comes with an adapter that puts you in a -30, which is a common offset, or without the adapter, when it's screwed in, the prism is screwed into holder, it's -40. In -40, it's in the nodal position, which means that the optical and mechanical and electrical center of the prism is directly concentric with the plumb line. So when the prism turns, the optical mechanical center is dead on the plumb axis. This is very important for precise short distance surveys, traverses, or any type of layout where you need a precise angle and distance location. This offset can be tested by pointing at the center of the prism, the apex, with your total station, and then having your rod man turn it back and forth in azimuth or up and down in tilt, and you will see that the apex of the prism stays directly on your instrument crosshair. It doesn't move. Whereas if you change it to the -30 or a 0 offset prism and do the same test, you'll see that is when you turn it in a rotating adapter, of course, that holds it over the plumb line, that it moves off center. A nodal will not move off center. So that's the advantage of a nodal. The rod man does not have to try to perfectly point it back, because he's never going to be perfect, face it. So the nodal point eliminates that potential field error and allows you to have precision angles at all distances. The 30mm adapter is like so. It just screws on the back of the prism, easily to convert from 40 to 0. I'm sorry, -30. Okay, easy conversion. We also have it in the mini prism, which is a 17.5 offset. The nodal is different on different physical diameters and heights of the prism. That's what really determines the nodal, and the offset is the height of the prism. So to get nodal in a mini prism configuration, it's 17.5 millimeters.